Let's try to get O1 to create a problem-solving prompts, reasoning prompts for Groq models, since Groq models are super fast. And we'll try to get them to solve mathematical problems, which LLMs can't by themselves solve, like high-digit multiplication. So that's a simple and create a data set for the problem set. Let's begin with that, actually, math.py. Let's ask create. Let's first see. Well, actually, let's create 5-digit by 5-digit multiplication, or actually, let's say create a script which can create a math problem data set of multiplication of n times n digit number times n digit number. Let user specify the digits and let's specify the digits and the number of examples. Save the data set to a JSON file along with the correct results. So this should write a script which allows us to create data sets, hopefully. Why is this happening? Math.py. Overriding. What is it? Oh, I shouldn't have used math name because that's a math test, let's say. Okay, yeah, that module is already, it's an import, default import for Python math, so I shouldn't have named it math.py. Anyway, okay, so this is going to create a data set example usage. Let's create 5. Number of examples, let's just do 10. And when we run this, it should create our data set of 5-digit numbers and their multiplication. Now let's just test to see how Groq would do normally. I'm here at Groq's console in documentation. And I'm just going to grab this example Python code, be able to call Groq. Now let's say Groq call.py. And here, let's paste this example, use Groq. It's going to use Llama 3 8 billion. Doesn't matter. We can change that later. Use Groq API to let's use Groq API to try to get the model to solve the problems in our let's give our multiplication data set as an example data set and see how many we can get correct. Save the result in a JSON file. Let's see what it does. We can modify it. Okay, it's going to grab the number and pretty much very straightforward. Okay, so it's going to grab the numbers and then send them. Much to Groq API, please provide numerical answer in between. Let's say, so we can easily parse it in between answer tags. And here I can say, please, I just selected everything and Control-Alt to go to the chat. Please parse the answer properly. So because you can respond in many different ways, we are just trying to make sure we are parsing it correctly. This should work. So we're going to ask each question separately, get the answer, and then see what the results are. So we are doing this synchronously. Let's see how it goes anyway. Groq is pretty fast. Oh, we got 0 accuracy. Model answer. Okay, it's giving the answers. Well, it's still the wrong answers, but it's giving the commas. Okay, let's just say Control L, remove the commas from the model answer, if any. So we match the answer. So it answered wrongly, but this is gonna look for a perfect match. See, so therefore we're gonna need to remove the comma, except I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Let's run it again. Okay, it's still 0, but at least we can accurately now match it. So this is good. So at least we know now Groq 8 billion, Llama 3 8 billion. It doesn't really matter which model we use, I guess, because we're just going to try to get them to improve. And actually, if you look at the limits, we can try to use the latest Llama 3.2, but their tokens per minute is pretty low right now. Versus if we were to use this model, it's 20,000 per minute. Let's just stick with this. Okay, so now with this simple prompt, which is a user message, we get 0 correct answers. Now we want here now. Let's try this. Let's go to open. So we want O1 to generate some kind of reasoning system message for this model to see if we can create something that will improve this performance. This is great because we can easily test this. We have an eval, right? Eval is important. So let's go to OpenAI docs and grab, let's go here, go to docs, go to reasoning, and just grab this example for the example call. Come back here. Now let's again select everything, Control L. Let's give this example. We want to use O1 mini model to generate a reasoning and problem solving thought process as a system message for the smaller Groq model. Then we want to pass the system message to the Groq model and see how it performs. Let's right. Let's also save the system message itself to the results JSON file, so we can keep track. Hopefully. Okay, so this is let's apply this and then check it out. Maybe I'll zoom out a little bit. Let me know if you have difficulty seeing this. This apply sometimes takes a minute. Let's apply it again. Accept. Okay. Again, we should say here return the okay, generate a reasoning and problem solving thought process for multiplications problems for an LLM to make its accuracy better. Return the thought process. Return generated problem solving thought process system message. Let's say for solving multiplication problems. For an LLM to make its accuracy better. Return the system message in between system message tags. Okay, let's say here we need to parse that too. Parse the system message properly. Apply this. which is pretty instant. So okay. So this is going to be one time try, or one to read a system message, and then we're going to test it with Groq on the 8 billion model, Llama 3 8 billion. Let's see how it goes. We should have also said save the system message to a .txt file so we can read it more clearly. Accept, and then let's run this now. See if we get any improvement right away. Oh, it said violating usage policy. Oh no. Well, maybe this is not going to work. Well, that's sad. I don't want to keep trying. How about we? Wow, man, this is a bummer. I thought this might happen. Wow, this is sad. I don't want to push this. I don't want to get banned from the API. Hmm. Okay, you know what? In that case, let's call. Okay, O1. All right, you know what? We can fix this because O1 Mini would have been the best one, but we can use Groq for this as well. Okay, let's do that. So let's actually use Groq 3.2 70 billion text preview, which hopefully should be the best one. Or do we have 405 billion? I think they removed it. Okay, let's use the 90 billion. So let's select this all again, Control L, instead of using OpenAI for the thought process generation. Let's use Groq with this model. So same difference. Yeah, we're just going to leave Llama to generate it. Apply and accept. Okay. Right on. So everything remains the same. Now let's run this. System message. Okay, it wrote wired format. Okay, so this is great, but it's still, it immediately tested itself and it's still got 0%. Maybe 5 digit by 5 digit is pretty hardcore. But this system message that was generated, and it looks nice, uh, actually. And we are using it, but it didn't help us. So this math test, let's actually reduce this to 4 digit. Let's recreate the problem set. And let's run the Groq call. I guess we should have separated a regular Groq call. Basic, let's say Groq call. And then here, let's do Control K and refer to the Groq call since we all have all the information there. And then let's ask this to actually just test itself without a system message against the data set. Let's implement a simple Groq call, let's say, to test itself against the data set without a system message. Okay, let's see what it does. It should do everything else. Yeah. So it's still going to save the results, but we're just not going to use a system message. Okay, so we can run this and test because we have created our multiplication data set is now 4 digit by 4 digit. Basic Groq call, run it. Again, it gets 0. Okay, basic multiplication result is 0. So now we can call the Groq call. Let's say we should say Groq call with sys to refer to the system message, which is going to be generated by llama 3 to 90 billion. Let's run this again. Again, 0%. Multiplication results. Did it even improve it? Did it get closer? It seems like it actually gotten closer. Look here, it was diverging immediately on the third digit. Now it's actually got much closer, it seems. Well, not so. Yeah, it got closer here as well. So we need an iterative way. So it actually got away here. So this system message really didn't help it. So therefore, we need to make this iterative. Let's say, okay, let's use the chat. We now need iterative way to improve the system message. Let's pass the uh, smaller, let's say smaller models, test results back to the system message model along with the latest system message and ask it to improve it. So this is not the best way to do it, but it's a good start. Now need the iterative way to improve it. Because we're not keeping history, we're just going to pass the last message. Let's just go with this for now. And then perhaps we can improve it. The system message and ask it and ask it to improve it for better accuracy. Okay, generate system message, current system message. So it's just going to try to modify this function, but it's going to please improve the system message. So it's not going to, well, oh, okay. So if iteration, max iterations, generate system message. But we want to probably separate the first iteration, right? Because we're not going to have a system message in the first iteration. So therefore, we want it to send a normal message and don't have all this in it because we're not going to have results and we're not going to have a current system message. Let's say, please write uh, please keep the original system instructions. Let's say instructions for the system message generator for the first iteration. Should understand that. Okay, so now it's going to split it into two functions. Generate initial system message, generate improved system message. Okay, now apply to the entire file. So now it should work. So now we have generated a math data set, just 4-digit by 4-digit multiplications. We can test it against a small Groq model, and we can write the results. It's also saving a system message. Good. Well, we can save it without a system message just to see how it performs. It actually gets all of it wrong. Total problems 10, total correct answers 0. Then we can make a larger Groq model, create a system message for it, and more of a thought process, problem-solving thought process for multiplication problems. And then we can test this and see the results. It still fails. Well, 8 billion is very small, such a small model, but now we're going to try to iteratively improve this. Let's run this. I hope we don't hit any rate limits, but see how it goes. Okay, iteration 1, accuracy 0. Iteration 2, accuracy 0. Iteration 3, accuracy 0. Yeah, I think we just hit the rate limit and now we are being, well, I think Groq has auto back off due to having such small rate limits. Nevertheless, we still got 0. We can actually look at these and see the system messages for each one. Seems each one of them are seemingly different. Like this one, for example, says choose a methodology, determine if the multiplication can be done mentally, requires a step-by-step process. Okay. We went through it all and it's all 0. So 8 billion cannot do 4 digit by 4 digit multiplications, even with extended system messages. It just wasn't able to. And here we can see the invalid response. So we got some invalid responses. And it's also probably not following the system message properly. I see. Improvement prompt. When we generate the improved system message, we put it here, and our prompt only says to return the answer in answer tags. Therefore, let's do this. Let's add this to the system message too. And we just want to add a string. Please provide the answer and answer and answer. So whatever the system message, we still pass this that it should return its answers and answer tags. We also have it in the prompt. So this too should work. Now at least let's run this again. Now let's clear these, except the data set. And maybe let's not do 10 iterations. Where are we choosing the iterations? Max iterations, 5. Okay, 5 is good actually. Let's test it again. Maybe some of these invalid results were correct. Let's give it a fair chance. 0. But at least now we shouldn't get, yeah. It's getting close, but not there. At least we haven't gotten any invalid results, although we still get, and it seems the system message is getting larger, which at least in the second iteration, it got larger. In the third iteration, it got larger still, but to no avail so far. Okay, so 8 billion is not going to work with this, but let's not give up just yet. Let's first create a new math test with just 3-digit multiplications and see how the model does without a system message, and see if you can just to see if you're actually able to accomplish any type of improvement. So let's delete all this because let's make sure there's no invalid results. No, and let's so our new test set includes 3-digit by 3-digit. We can make the basic Groq call without a system message. See how it performs. Run it. Oh, it again got 0%. Oh man. Yeah, it just failed. That's surprising. Okay, 3-digit. You know what? Let's do 2-digit multiplications. It should be able to do that, right? Let's run this. 70%. Okay, maybe this is. Let's run it again, see how it does the second time. Just to see if we get. Oh, see, this time it's 80%. So we're going to get some variability. So therefore, let's create 15 examples. I don't want to do too many because we're going to hit the rate limits. We're going to have to wait. but 15, let's do 50. And I run the basic call again to see what accuracy we get. So, I mean, this will be interesting. Well, let's see if the system message improves this 80%. So we got anywhere from 70 to 80. So now we can do this. So we're going to try to solve the two-digit by two-digit problems. Llama 8 billion does up to maybe 80% accuracy. Let's run this again to be sure. It's fast, but we're hitting its rate limit. I suppose that's what's happening. Llama 3, 8 billion has token 30,000 even. Nevertheless, okay, 86%. So now let's test it with the system message generator. So we are going to get Llama 3.29 billion to write a system message for the 8 billion to solve multiplication problems. Our first system message will be a problem-solving thought process for solving multiplication problems. And we're going to test this 5 times. Let's go. Okay, we got 66. Actually, we got worse accuracy with this prompt. You can see each example, and at the end, we get the overall accuracy. This is interesting, for sure. Again, for those of you, 86.68. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. So that's good. Quite a system message. I mean, this can be improved in so many ways. See if you get to 100%. We're not keeping history, so system message generator only gets to see the last system message. So iteration 3 knows about this accuracy. Let's take a look. It knows about the previous system message, total problems, correct answers, and accuracy. Based on the results, please improve the system message. We could, pass these actual results too, if you want it. Oh, it dropped to 73%. Here is the third one, third system message. While this is going, let's try to do that. So let's select this script, Control L, and you know what? Let's copy this so we make a new script. So this one doesn't get. So this is a pretty general feedback mechanism. It only gets the accuracy. Let's make this detailed feedback, and let's instead work with this. Let's clear this. Actually, I'm going to Control A, select everything, and Control L, start a new chat with this detailed feedback. We got up to 86.67, but we don't know if it really improved. We have seen it do 80%. Still seems a bit of an improvement, but here, let's see, let's pass previous full test results of each individual test as well. So we're going to pass each individual test. Yeah, detailed results. So we're going to pass the whole results for additional information. Okay. So this is the detailed feedback. Now let's try this. But before we do that, I wish we would establish a baseline of accuracy by running this basic Groq call like so many times. Um, but we are, I suppose, getting it. I mean, if we go beyond 90%, I guess for simplicity purposes, we can say we have significantly improved it. But let's run this. Maybe a small model is just overall not that great for following, thought processes. She got 60%, 73 in the second iteration. We are overriding these, by the way. Let me delete the 4 and 5. Let me delete the 3 as well, because we're still waiting, hitting the rate limit. This is exciting. After this, let's try with 3.21 billion. It's just we're just going to have to wait. I wish at least the 1 billion would have more tokens per minute. Oh, we can run this here just to test it in the basic Groq example. Well, look, we got up to 80%. So we got incremental improvement. Let's just run the Python basic Groq with the 1 billion. We got 46.67% accuracy. Let's try it again. We again got 80% here. Oh, 20%. Let's try the 3 billion because there's a 3 billion variant. That's 60%. Let's see again. But these are fundamentally much better models, right? They're trained so much better. We are using essentially here for our test Llama 3, not even 3.1. Oh, in the last accuracy drop. So, okay. So therefore, let's delete these. Final result, which was, I'm not sure if this was the final result really. Uh, let's use the detailed feedback and let's use 1 billion model. Okay. Let's see if 1 billion is able to improve with a better system message. See, it's actually drop with the system message, it actually drop super bad accuracy with this system message. Maybe small models are not good with instructions. We are passing the full results of this invalid response. See, even it's a small model. Oh, we are getting invalid response. It's not following the structure. Are we still passing? Generate improved system message. Yeah, we are, sorry. Yeah, we are still passing it to return it in between answer tags, but it just doesn't want to follow it, I suppose. So there's no point in testing it if it's not going to follow that. So we can maybe say, because we're asking it twice, both in the prompt and at the end of the system message. So let's cancel this one and let's instead test 3 billion because if we are getting invalid, if the model response is invalid, let's print invalid response. We don't need to print the model response. And we're now going to test 3 billion. Yeah, we don't want to get invalid responses. Okay, 3 billion got 66.67. With first go, first system message. See, this is not getting invalid now. That's promising. Where 1 billion is exceptionally small. You know what? Maybe I should have used OpenRouter for this because I'll put this code in my Patreon, and I don't know if everybody has Groq API, and it's currently very limited. So instead, let's go to OpenRouter. Well, we'll make an OpenRouter variant. Docs, uh, here, right here. Let's instead use this. We don't need extra headers. Let's let's modify this detailed feedback to rename OpenRouter so we can use any model. And our accuracy didn't improve in iteration 2. We're still ongoing. The rate limits for these models are smaller, so we are waiting. But while we are waiting, we can modify this to Control L and grab this example, OpenRouter call, paste it here. I'm going to say modify this script to use OpenRouter instead. And we don't need to use extra headers. Okay, good. So it may make mistake with model names, but nevertheless, this should work. Apply, accept. Now we can actually just go find a model. Llama 32, 3 billion instruct. This is the one we were testing. Replace these models. This is the problem solved. Okay, we can say up here, system message generator. We can give this a model name, problem solving model. And so we can easily update it right up here. Model solving model is going to be the 90 billion. Let's say 3.290, search for it. Okay, this is the vision instruct, but it should do text tasks as well. And here, we're gonna say system message generator. Cursor tab is doing it for us. Content improvement prompt. Initial system message generate improved. No, this is not problem solving model. This is system message generator. And here is the problem solving model. Okay. Well, the Groq API is still going. It's very fast with these rate limits. It's just don't make it right. I mean, it just makes you wait. But in the iteration 4, accuracy jumped to 80%. That's interesting. Quite a quite the system message. We can actually test this, right? With our basic Groq call. Let's also make a OpenRouter version of this. Basic OpenRouter call. Router call. Please modify this to use OpenRouter like in, and let's refer to the OpenRouter example that we have already created. Okay, good. So it wrote the whole thing. We can just copy paste. Let's not waste an apply on that. Yeah. So let's see what happens in iteration 5. Maybe we'll get a pleasant surprise. So with OpenRouter, let's try something different. We're not going to hit rate limits with OpenRouter. Maybe we can choose better models, such as 405. MetaLlama 405 billion instruct. Let's use this as the system problem solving prompt generator. And we can test it against 3 billion. Yeah, 73. I think this may have been improvement, honestly. But let's test this OpenRouter one real quick. See how fast this one goes. Still sequential. We can make this async as well, but still like this. At least you get to see the results in sequence. Slow. Oh, invalid response. Wait. Oh, okay. We're just getting invalid response. Shouldn't have counted. Sorry. I thought 405 billion initial system message. I guess could have looked at it here. It says I will follow these steps. Oh, maybe you shouldn't say that. Thought process. Refer to the model as you. Refer to the model as you. You. Okay. Okay, we got one invalid response, but still 73% for 3 billion. That's pretty good. But this should make a difference, in my opinion. We should test that too. So we are getting Llama 3.1405 billion instruct to write a problem solving thought process system message for solving multiplication problems for a smaller LLM, and we are testing it on Llama 3.23 billion with 2-digit by 2-digit multiplications. And our first iteration returned some invalid responses, but it was at 53%. And second and third iteration is at 73%. So that's pretty interesting. Actually, we can see the system message and the results here. False. For example, here is a mistake, 94 times 47. It was off by, I don't know, something like 40. Basic open, let's test this basic OpenRouter call to test any model. Like if we can, now let's run this to test Llama 3.23 billion instruct from OpenRouter, just to get a baseline, basic OpenRouter call. Let's see how it performs without a system message. So 73% looks impressive here. Let's run it again. Because without a system message, it did 46%, 47. This is llama 3 billion. So these are improvements. Let's run this again just to be sure. Look, it returned 46.67 twice, but with a decent system message, it was able to return 73% here, 53%. Okay, so what if we ran this more? Right. We can't really do async anyway because we need iterative, get the system message. Next iterations. Let's make this 10, just for fun. I know it's going to take a minute, and I'll explain the process again while this is running. So we have a math test generator. Let's rename this. We have a script which generate. You give it how many digit by how many digit multiplication problems you want. You give it how many examples, and this creates a data set, multiplication data set with two numbers and their multiplication results. And using basic Groq call or basic OpenRouter call, you can test models without a system message to see how they perform and write their results here. For example, when we tested this, we got 50% correct. And then using Groq call with system message, we tried Llama 3.2 90 billion to generate a problem solving thought process system message for solving multiplication problems. And we use that as a system message with 3.2, sorry, for the Llama 3 8 billion. It didn't go so well. We are adding this to the end of system message so that the answer is provided within answer tags. We also say that in the user message as well, somewhere here. But then so with this iterative approach, we were only passing the system message, previous system message, plus the accuracy. So we built a better one where we are passing the previous system message, plus the accuracy, and asking it to improve the system message for better accuracy for solving multiplication problems. But in this case, we are passing all the examples, and we modified it to use OpenRouter. So we can use any model instead of Groq, because Groq has some strict rate limits, which we keep running into. Even though it's fast, then it slows us down with the automatic back off. Okay, we're getting now about what we were normally getting. So this may also be a thing that we start with a system message. If the initial system message is not so good, it could be that iterations on it might not also be so great. But let's see. Oh man. Well, the system message is changing. We are, after all, using the Llama 3.2 3 billion. After this, let's use a different model, a 70 billion model. How about that? We can use meta. Let's find browse. Let's just search for meta 70 from OpenRouter. Let's use meta llama 3.1 70 billion instruct. It's taken a long time. But this project files for this will be available at my Patreon, and If you're interested in becoming a patron, you can talk with me every Sunday in the AMA meetings. Plus, you'll have access to all the projects I've generated, all of which you can actually find on my website at cohive.live. If you're a patron, you can click this code download link and it'll take you to the appropriate Patreon post, and project files are attached at the bottom. But you can watch the videos associated with those projects for free at my website, cohive.live. Just remember that. Okay, in iteration 4, accuracy improved. I hope that wasn't by chance. Let's keep this going since we started. I suppose we can run it again. We can run the second one here on the second uh, command prompt. Just so you know, you can close your terminal prompt windows by clicking here. You can see which one is selected. See, I can kill it, and I can create a new one by going to split terminal and selecting command prompt. Let's make sure we've set our models correctly. So Meta Llama 3.17405 is going to write the system messages, and Llama 3.17 billion is going to answer them. But let's test the 70 billion first with the Groq call to get a quick result. Sure to yeah, just we need the actual model name. 3.5 billion, 70 billion versatile. Yeah, run it. 93%. So therefore, so this is doing really well on all of it. So in our math test generator, let's actually generate 3-digit by 3-digit. We need to run this here. Python math test generator. Now here's our data set. Let's run the basic Groq call again to test the 70 billion against the 3-digit by 3-digit, and it got 13.33. It's not very good. So, okay, let's run it again just to get another baseline. 6.67. Okay, we are already hitting the rate limit, but so it's pretty low. We know that. We can stop this. Now we can just run the OpenRouter with the iterative problem-solving prompt maker. Python, OpenRouter. Yeah, this one. And we can remove the copy at the end of this. Okay, it's going to be slow, but our accuracy here was steady at 66.67, but now started to go down. Not sure why. Oh, wow. Already we're at 20%. My guess is that larger models handle detailed system prompts better. Let's see if you're not getting any invalid results. So, see how this goes. I had high hopes for this. But this is testing the 3 billion model. This is testing 70 billion. Here's went to 0. And by the way, this is overriding now from iteration 2, overridden this one. We all got it wrong. Got it all wrong. This was the system message. It went back up to 13. So this is pretty interesting, right? This definitely should work in theory, but it probably needs better feedback, possibly. How are we doing here? Oh, it went down again here. And this went down to where it was actually when you tested without a system prompt. Oh, wow. This one went up to 73%. It's this one. Initiating enhanced multiplication problem solving protocol, phase 6. Based on the analysis of the previous results, the system has been further refined to address specific accuracy concern. Shouldn't have presented these, but so what? This updated protocol incorporates additional checks and error handling, implement a more sophisticated digital reversal detection and correction mechanism. I suppose the system message generator needs additional instructions as well. But whatever it said, it worked. Up now, it increased to 73.33. Here, we just tested this for 5 times, and it got up to 20%, which is somewhat of an improvement, I suppose, because this one is set to 5 still, makes iterations. We can change this to 10 and run it again just for fun. Oh, it's no longer copy. Python, OpenRouter with detailed feedback. Oh, so slow. Okay, 6.67 for first iteration. Generated README for this, for Patreon. README.md. Okay, let's use Control L with this. Let's refer to all the basic Groq call. Yes, we can add it here. Basic OpenRouter, Groq call with system, detail feedback, and OpenRouter detail feedback. Please create a simple README explaining how to use this project and the differences between files. Okay, don't mention Git. Okay, ensure a multiple file is in the same JSON. Oh, we haven't, sorry, we forgot to add the math dataset generator. Generates a dataset, tests. Good. Oh, this is great. It's the message. Yeah, this is awesome. Copy this, Put it on README. Requirements. .txt. Requirements are conveniently here. Oh, they're not. But I know it's OpenAI, Groq. I believe that's it. Groq. Yeah, should be it. Our accuracy was 60%. This is still going. Okay. So, in my opinion, we do get improvement with a better system message. I mean, we can see it here. Oh man, the terminal sometimes gets mixed up, but we definitely went up to 73% accuracy. And then we suffered a little bit. Uh, it was iteration 8. So we can, it was this one. But nevertheless, in comparison to the baseline performance of the model, this thought process system messages did work well, in my opinion. So I'll put this into Patreon. I hope you enjoyed this. I hope you found it useful. And yeah, that's it. Well, thank you for watching. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one on one. Check those out as well.